afternoon, and thank you for joining us. My name is Michelle Nellenbach. I'm the Vice President of Strategic Initiatives at the Bipartisan Policy Center. And I am just so thrilled that you could join us for this amazing panel of technology and AI experts. For those of you who are expecting Tom Rumanoff, our Director of Tech Policy, he is at home with a brand new baby, so I have stepped in. So today's event is the first in a series of 2 events looking at AI impact assessments. AI impact and assessment language matters in policy. And in case of AI, there's no consensus on how to define the scope and terminology used for impact and risk assessments. BPC staff found over 70 different frameworks in the world. And so how do we pull that all together so that we can adequately assess AI modeling? So today I want to introduce our panelists. They are really, as I've told my colleagues at BPC who are not in the tech space, that we have got the 3 rock stars of technology policy. They are really the experts you want to talk to about AI and risk assessments. Their full bios are on our website, but for now I'm just going to introduce them with their titles. We have Dr. Fei-Fei Lee, the co-director of Stanford Institute for Human-Centered Artificial Intelligence, the Sequoia Professor of Computer Science at Stanford University. Dr. Daniela Rus, who is the Deputy Dean of Research, the Schwarzman College of Computing at MIT. And finally, Dr. Marshall Hebert, the Dean of the School of Computer Science at Carnegie Mellon University. So thank you all so much for joining us today. I'm going to turn to them each in turn to just give a brief remarks about where they think we are in terms of AI and what the latest is on AI impact assessments. And so with that, I'm going to turn it over to Dr. Lee.
Thank you, Michelle, and thank you everyone for the invitation. And just a great honor and pleasure to be presenting here with 2 of my colleagues and friends in AI. I also want to point out it's very cool to present on a day with the most number of 2s in our century. So go figure. So I'm asked to just open very briefly to talk about where AI is going, the major trend and the policy implications. So I thought of 3 things I want to briefly touch on, and then we can dive in later. One is that I still see the deep learning dividend is going strong and healthy. The benefits of the past decades of technology development on deep learning will continue to deepen and widen in industry and commercialization. We're seeing that big trend in large language models. We're seeing that in computer vision driven self-driving car technology. We're seeing it in applications from healthcare medicine to sustainability to many other areas. So that is going very strongly. Given this, it's important to see policies that continue to encourage this healthy entrepreneurial competition, but with keeping in mind the importance of a tailored regulation that establishes the important critical guardrails, ensuring fairness, privacy, security, and other important human and civil rights issues, especially in critical application areas. That's the first trend. Second is humans matter in AI. It matters even more in tomorrow's AI. And AI today as a field is deeply traditional. It's a still deeply traditional field that lacks good human representation, from its K-12 outreach all the way to academic and industry and government leadership. This calls for doubling or tripling down on policies that make our pipeline more inclusive, reach out to traditionally underserved and underrepresented communities, but also to create better work environments and ensure inclusive leadership all the way through. Last but not the least, since we're here talking to a lot of policy thinkers and influencers, invest in the future. Today's deep learning dividend we just talked about come from at least half a century of academic research that brought us this converging technology of things like chips, big data, ML, machine learning algorithms. But what is in the future to ensure our country's leadership in technology, AI, and beyond, we need to invest and double down on today's academia, STEM fields and education, and cross-disciplinary human-centered research, such as AI and economics, AI and brain sciences, AI and ethics, quantum computing, sustainability, democracy and governance, medicine, and more. And federal government especially play a huge role in this. I don't want us to look back one day in the future in frustration that our federal government did not do more to fund academic scientific research in our country, missing a historical opportunity to ensure the future prosperity of our people and economy through innovation. And last but not least, I know Daniela is here. She was one of the leaders in the NSC AI work recommending multilateral AI research institute with the countries and regions, and I think that's that share our values, and I think that's really also important. And Stanford's HAI is doing research on that front as well. So these are my 3 points.
Thank you so much for that, Dr. Lee. I'm going to now turn to Dr. Marshall Hebert for some introductory comments from him.
Thank you, Michelle, and thank you for this opportunity. As Fei-Fei indicated, progress in AI and machine learning continues to accelerate. That progress is translated to a rapidly exchanging range of applications. But unfortunately, this progress is achieved much faster than frameworks are being developed for understanding the risk and the impacts of the technology. So let me spend just a couple of minutes going over a couple of examples of the hard challenges that we face here. Fairness and bias. Fairness, bias reduction are essential for AI systems. This goes far beyond generate statistical aspects such as understanding the effect of unbalanced data. It requires a deep understanding of notions like fairness and bias in the context of specific application and their desired outcomes. Developing a common language and a set of approaches for this is still open. This is complicated by the fact that in many application domains, the data is human generated and is therefore subjective, biased, and error prone. Understanding the role of this human generated data requires reaching out far beyond the core AI area, looking into social sciences, psychology, etc. And these approaches are not yet fully developed. Data privacy. AI, machine learning systems, their reliance on data brings up a range of issues, from data privacy, reducing the impact of centralized data aggregation. This is obvious in fields of application like healthcare, but is equally important in virtually all of the fields of application. Examples include the idea of bringing the computation as close to the data as possible to reduce data movement, the design of secure distributed learning system, and more generally, the idea of sharing without showing data. Safety and reliability. Assessment of risk and impact requires understanding and modeling of the performance of AI systems and their behavior. In particular, effective predictive model of performance that can place bounds on the performance of AI systems operating under different changing conditions. We're at a disadvantage as well here. For classical engineering systems, we have at our disposal a wide array of tools, of formal methods, of best practices built over a couple of centuries to evaluate and characterize systems. For AI systems, we do not have the equivalent toolbox. For example, the performance of an AI system depends not just on its design, but on the data that was used to train it. In addition, even when individual components can be characterized in isolation, measuring the outcomes to an end-to-end system in the context of an application remains challenging. Transparency. Transparency about how an AI system works gives individuals the opportunity to appreciate the effects of the decision-making process in the application area. There is considerable research on the technical aspects of this question, for example, explainability in AI systems. But transparency does not necessarily mean that algorithm and data usage must be understood. In fact, at a more practical level, we need to develop best practices and frameworks for making AI systems in each field of application auditable, audits that can then be shared to mitigate risk and increase accountability. So these are just a few examples of the challenges that we face in assessing AI systems. Thank you again, and I'm looking forward to the discussion.
Thank you so much for those excellent opening thoughts. We clearly have a lot to cover. And finally, I just want to go to Dr. Daniela Rus to provide a few opening comments of her own.
Hello, everyone, and I'm so honored and happy to be here with you and my colleagues and friends. I'm so happy to build on what my colleagues have described as central topics that will decide what our collective future with tools rooted in AI look like. Now, in my role as the director of the Computer Science and Artificial Intelligence Laboratory at MIT, I'm often asked to talk about the impact of AI. What would rapid advances in AI mean for our lives, our jobs, our future? And I would observe that AI is central to so much of our work. And I'm personally very optimistic about what the future holds. I believe AI will improve our lives, will improve how we work, how we live, how we learn in so many ways. In many ways that we have only begun to imagine. But my optimism rests on the belief that we, as educators, business leaders, policymakers, we have the ability to take action to control the challenges that the technology creates. And to be frank, we can only achieve the best outcomes if we address these big challenges. Fei-Fei and Martial already outlined some. Let me round it up by outlining some technological and societal challenges that we have around the use of AI technology. So on the technical side, it is important to know that today's greatest advances are due to ideas that have been developed over the course of many decades, as Fei-Fei explained. And these ideas are recently enhanced by vast amounts of data and computation. This actually shows the importance of investing in idea development for the long run. But now it is also important to realize that we also need new ideas. Without new ideas and the funding to back them, more and more people will be staying with the current techniques in deep neural networks, for example, plowing the same field, and the results could get increasingly incremental. So we need new ideas, we need major breakthroughs if we're going to manage the challenges in our way. We also need the computational infrastructure that is needed to enable progress. And in my mind, it's an infrastructure that can deliver to us data and computation like we get water and energy today, anywhere, anytime, with a simple turn of a knob. And we need the funding to have the infrastructure and to develop the new ideas. Now, if I were to stay focused a little bit on some of the particular challenges that today's techniques face, let me remark that a first challenge is the data itself. AI methods require data availability, which today means massive data sets that often have to be manually labeled, and they're not easily obtained in every field. The quality of this data has to be very high, and it needs to include critical corner cases for whatever is the application at hand, because if the data is biased or bad, then the performance of the model using it, the algorithm using it, will be equally bad. Second, the current systems are primarily black boxes, meaning that they're so large, it's very difficult for users of the system to understand the system's workings. And this means that it is difficult to detect behavior that is abnormal from a safety point of view, and as a result, it is difficult to anticipate failure modes tied to rare inputs that could lead to potentially catastrophic consequences. We also have some robustness challenges, And we have challenges around how AI systems interact with people, essentially understanding that AI doesn't currently have social intelligence. And so these are some examples of technical challenges. We also have societal challenges. And while I believe strongly that the spread of AI will make our lives easier, we also have to think about how some of the roles it can play will displace work done by humans today. So we need to anticipate and respond to this economic possibility. Also, the lack of interpretability leads to significant issues around trust and privacy. And we really need to think about this. We need to develop an ethics and legal framework for how AI could be used for the greater good. And finally, I would like to remark that the spread of misinformation continues to be a big topic, and social media platforms struggle with their response. But as deep fakes get better and widespread, this problem will become more urgent at an individual level and also at the national level. One more thing, as we gather more data to feed into AI systems, the risk to privacy grows. And that means that authoritarian governments can leverage the AI tools to curtail freedom and democracy in countries around the world. And this is a serious challenge. But I will say that the research community is working on identifying solutions. The solutions necessarily have to be at the intersection of policy, technology, and business. And while it seems daunting that we have this really powerful technology delivering superhuman capabilities, at the same time, we have these very important challenges. So really, where to begin? Now, I believe it's important to build a kind of a common understanding around 5 vital questions. First, it's important to understand what technology can do. What is really possible with the tools that we have today. Second, it's important to understand what we can't do, what is not possible. Third, we should consider what should we do. Fourth, we should consider what shouldn't we do, because there are things that we should rule out. For instance, better tools that enable disinformation. And finally, what must we do, because we do have an obligation to consider how AI technologies can help the world.
Well, that was those were great. I love the 5 questions. I think those are the exact topics that we need to cover. You all hit such incredible. There's a lot of privacy, transparency, a lot of issues that we need to get into, and obviously, a risk assessment, impact assessment done correctly could help mitigate some of those concerns. So I just want to dive in with the questions right now. I think we'll start in general terms around AI. I'm going to go to Fei-Fei first. Concerning bias in AI, we talked a lot about the problems just now. What are some of the potential solutions?
Great question. I'm sure my colleagues have a lot to say as well. I want to first set a stage right. The responsibility lies within people. I want to make it very, very clear. A lot of sentences start with AI is biased in a way that's not a grammatically wrong sentence, but truly it's the designers, the developers, the practitioners, the users, the decision makers. There's a lot of people behind what AI is, and the bias and fairness issue, I think we all should take it very seriously. It's on people. As a system, AI as a system, from the design of the problem, the selection of data, the labeling process, all the way to the design of the algorithm, the learning algorithm, the inference algorithm, all the way to how we use the results, bias can creep in everywhere. So it's not one point, and it cannot be one solution. So I think it's really important to recognize that from educating our developers, our technologists, to setting up application guardrails. It's a pipeline of issues and a pipeline of solutions involving education, policy, and just societal awareness.
Great. Daniela, did you want to get in on?
Yeah, so I completely agree with Fei-Fei. We can apply some technological tools to make forward progress. And so, for instance, one set of tools we have available is to understand the data spread, to understand what is overrepresented and what is underrepresented in the data used to train a machine learning model. And if we can understand that, then we can, in some sense, computationally adjust the data so that the underrepresented items in the data set get elevated to higher representation, and the overrepresented items get lower representation in the data set. We can also analyze the data used to train a machine learning model. And because there is an immediate correlation between the uncertainty in the data and the uncertainty in the model, we can understand what is missing in the data set and create new training data to target those aspects of the application domain. So so the solutions are really interesting. Just as Fei-Fei said, we really need solutions that involve education of people. We need policies and guardrails. Technology can also help in this process. And for example, in this way I described, where we can analyze the data and improve it so that the uncertainty of the model is reduced.
Great, thank you so much. Marcial, is there anything you would add?
Yes, I want to come back to Fei-Fei's mention that we can't think of AI on bias in a generic way, as a generic AI type of system. We need to think of it in the context of an application, in the context of an entire system. Let me give you an example that one of my colleagues, right, Danny, gave me. This is a system that does prediction of possible lead poisoning in a household, with the idea of giving an alert so the household can call and get help. This is a case where the machine learning piece of this is by individual measure of that machine learning piece is unbiased and fair. The data is balanced, it passes all the tests on all this. But then the entire system, it turns out, seemed to leave out a part of the population. It turns out that the reason is that when the output of the system, the machine learning, the classification system was used, they would call the household in English and immediately miss out on a callback from a large part of the household. So this is just a very simple example of what that means, of being careful of thinking always in terms of a very specific application system and goals and outcomes.
That is an excellent example. I think obviously, as Daniela said, I think AI has incredible potential to improve lives. Like if you could figure out a way to carry out that project around lead in people's households, that would be significant. But sorry about that. But to your point about the data, in some cases is often incomplete. It is itself biased. Has there been one particular promising solution that y'all have seen that we should talk about?
Go ahead, Daniela. You were going to start.
I was going to say in my group, we have developed a solution that essentially implements the idea I tried to conceptualize for you. Analyze the data used to train the model, understand the correlation between the uncertainty in the data and the uncertainty in the model, fix the bias in the data, and augment the data with data items that target the part of the training domain that is under represented. And in fact, we have shown that this approach is very effective at debiasing images, so you can train on regular image sets that include faces where we know that the darker skin colored faces are underrepresented, but nevertheless we can fix those data sets to get better outcomes. So we can kind of remove the racial bias in data sets using this method. We can do other things with a similar method. We have an upcoming publication that shows how we can look at clinical trial biases to improve the outcomes of clinical trials. And this paper is coming out soon, so I can't get into too many of the technical details for that reason. But the point is that we can save hundreds of millions of dollars if we use these techniques to improve clinical trials that ultimately lead to better treatments, better medicines that support everybody, that support people. And that's really exciting.
That is. I look forward to seeing the paper. Fei-Fei?
Great to hear technical solutions. I'll take a different approach since, as we all say, there should be integrated solutions is the approach of education. I think it goes back to the people-centric point of view that whether it's a fairness problem or other ethical social problems of technology, it is so important to create a new generation of technology leaders who come with all backgrounds, especially from the underserved and underrepresented community. So since 2015, some colleagues and I have co-founded AI for All, a nonprofit national organization on K-12 education, focusing on training tomorrow's leaders in AI from students of underserved and underrepresented background. And our goal is to serve all 50 states of United States and beyond. And in 10 years, that new crop of workforce, especially leading thinkers in technology, policy, other areas of industry will represent much more fairly what our society should look like and be able to influence AIs tomorrow.
Fei-Fei, that is just such a great program. Congratulations.
Thank you.
Fantastic. I will say that at MIT, we are also interested in deploying education programs for AI. And in December, we gave the first offering of a course on AI for national security leaders, a course that aims at the current generation of people who have to make important decisions and may be supported by AI systems. And they have to understand how to interpret what comes out of an AI system.
Yeah, and I want to call out CMU as one of the almost 20 programs in the country to support students of underserved background under AI for All.
Absolutely, and I would add to that that we need to look at education at all levels and all technical levels. So, for example, we have a separate program looking at community colleges and how to promote AI education in those community colleges.
That's great. And I think BPC actually did a year-long project around AI, and that was one of our chief recommendations is that you do need, we got to start K through 12, and it should be multidisciplinary. As Daniela mentioned, the AI doesn't have social intelligence. And so we've got to have programmers who know that and can really interpret it and put that lens on it. And we certainly need to diversify the workforce So great point. Thrilled about your organization, Fei-Fei. So one follow-on question. Obviously, we are a DC-based think tank. We work on federal policy. These are issues of great importance to the federal government and members of Congress. And so, Marcial, I'm wondering, in what ways do policymakers need to evaluate the potential for AI? And what ways should they be thinking about how to mitigate the risks?
Yeah, so this may be a little bit too abstract of an answer, but let me try this. I think it's very important to not think of AI as a separate tool or a separate toolbox that has its own, assessment methods and so forth. It's important to think of AI as being part of every endeavor, every applications that we can think of. And it's very important to think of it in the context of those applications, not as a separate entity. And it's by thinking in this way that we can develop the appropriate assessment tools. The second one is, of course, to develop early those risk and impact assessments, so you can anticipate better the risk and the impact issue. The third one is what we already discussed, which is education and training, but not just from a technical standpoint, but for having a widespread understanding of the limitations of the technology. I think Daniela mentioned what the technology cannot do, right? And to have that understanding being very clear and being everywhere in the education system.
Great, thank you for that. And I should point out, as I have been very remiss in doing so, that we will take audience questions. You can use the chat function on YouTube or Facebook, and we are also on Twitter at #BPC Live. So I'm gonna dive into a couple more questions specific around impact assessments, and then we will turn to some audience questions. So please go ahead and put those in the chat for our folks. So looking at risk assessments, I'm going to go back to Dr. Hebert. Why are risk assessments needed?
Well, the risk assessment are needed to be able to quantify, in a way, to quantify the limitations of the AI system, so that we can understand the impact of those limitations and mitigate them. There are two things I think that are very important in those risk assessments. The first one is being specific, and the second one being dynamic. What I mean by specific is that in many cases, in many of the frameworks that are out there, those risk assessments are defined in a very general fashion. And as I said earlier, this will work only if we have enough specificity to the particular context of the application. So being specific is important. Being able to have more concrete operational aspects of those risk assessment is critical, so that they can actually be applied. The second is dynamic. What I mean by that is that we need to be able to deal not just with the current design of the system, not just with the current type of data, but recognizing that this will change over time, that the data will evolve over time. And so we need to take that into account in those risk assessments. So those are kind of two features of the risk assessment that are very difficult to implement, but that are needed in long term to be able to make them useful.
Right. Can I add one thing?
Yeah, please.
Oh. I totally agree with what Marcial said, and I also agree with his point of looking at this holistically. Just want to make one quick point. One is that you ask why, Michelle. That's the very important question. Well, from the discovery of fire and the first stone-made axle, humanity has been on this trajectory of innovation. We never stopped innovating, but our tools are always double-edged sword. And as we improve productivity, well-being, and make the society more, technologically advanced, we also create these tools that can harm people. So it's so important that risk assessment comes hand in hand with supporting innovation, and that kind of healthy tension is important for a society that cares about human values, that cares about human well-being, and cares about the shared human rights. And one really important point in this is that AI is, as well as other areas of computing, are very advanced technology. And this is so important that experts sit in the same room with the policy makers, with the risk assessors and practitioners, if we have a dearth of expertise in this room, the conversations and the decisions surrounding these critical issues will likely suffer. So this is where I think I'm the furthest from Washington, D.C. Among this panel. And I think it's great recognition on our part, on the sitting in the heart of Silicon Valley and west coast of our country, to recognize the importance of having this multi-expertise, disciplinary conversations together.
Fei-Fei, I so agree with your conclusions, and I just want to emphasize that we can't stop technology from advancing and changing the world. Just like you said, from the fire all the way to predictive machine learning. So we can't stop this progress, but we can stop to think about where we are and what the consequences are. And we can think about what kind of guardrails we need to put in place to ensure that the usage of these advanced tools is for the greater good. And this can only happen when we have in the room tech experts, policy experts, and also business leaders whose job it is to take the tech and turn it into products.
Great points. So I think Marcial touched on some of this, but Dr. Rus, do you have thoughts on in what ways impact should be measured?
Well, I guess impact should be measured in the context of the application, as Marcial described. There are safety critical applications that require different types of risk evaluation and measurements than applications where it's okay if the system makes a mistake from time to time. Nothing will go wrong if an AI system accidentally misclassifies my holiday photos. But there could be significant impacts if the AI is used in an autonomous driving scenario, and it makes a mistake, doesn't recognize, for instance, a pedestrian about to cross the street. So we have to really think about the risk in the context of a domain. And I think that we have opportunities to come up with solutions at the intersection of policy and of technology. So we are already beginning to see the beginnings of solutions to stabilize and ensure the safety of machine learned models for safety critical applications. We have the beginnings of solutions that begin to define how or unravel how the black box works. And this is important because if we understand what to expect from a model, then we know what the model is good for and what it isn't good for. And all of these have to be kind of aggregated together into even greater advancements. And ultimately, I think we need a kind of an approach to assurance of AI systems in the context of the domain or the application that they need to be used in.
So Dr. Lee, just following up on some of that. So obviously you need different assessments for as both Daniela and Marcel said, national security applications of AI. Getting more into the sector specific impacts, are there particular sectors, national security, of course, being one, where it would be important to create a unique framework?
Depends on how one defines a framework.
Okay.
You can't always make it so universal. For example, we at Stanford really are thinking hard a lot about what is the human-centered framework for this technology, which can be quite broad. But I agree with my colleagues. Personally, I work quite deeply in healthcare, and I do think there needs to be specific framework or whatever words we use that are uniquely important to healthcare. Every issue from privacy to fairness, to security, to human dignity, to surveillance, all this have unique risks and benefits in healthcare. And I think I was thinking about one of you, I think Daniela mentioned explainability. It's really intriguing, for example, to see most of us don't know how Tylenol works. There isn't much of a explainability in the molecular pathway of Tylenol's effect in human body. Yet it's a trustworthy technology or science that most of us would trust. So how did that come about? The framework is through FDA and its regulatory framework, the phased clinical trials, the experts involved, the testing, the data statistics. So that's really important in this industry, and AI is no different from Tylenol from that point of view. We need to take what's important in this sector and follow the or of course improve, but follow the framework. I do want to say that what works for FDA might not work for EPA, might not work for DOD. It really truly needs to be tailored towards different field. But the bottom line is, what's the society's value, right? What are the universal human values we care about? That is what unites possibly different frameworks.
Great, those are some really good examples of, and help kind of clarify some of the thinking around this. Marcial, have you seen any specific risk assessments that you think have gotten it right, and are they replicable?
Well, like I said, most of the risk assessment that are out there are very general and not really operational. So it's very difficult to answer that question in terms of success. But we can point to, for example, some of the ideas around data and data privacy, and defining what data should be used and should be not used in a particular system. And that's where we have some reasonable risk assessment in those areas. I wanted to make a quick comment coming back to the previous discussion, if I may.
Sure.
One thing that distinguishes AI from the other technologies that were mentioned in medicine, in engineering, and so forth, is that the time from conception of a system to actual deployment with users, or new technology and actual deployment with users, is considerably shorter in the case of AI. In other words, there is technology put in the hands of users long before we even know how to even talk about the risk of the technology. And now, for safety critical things, self-driving, drugs, and so forth, there is some regulatory framework around it. But for things that are more like question answer systems, things like this, there is not, and there is a risk associated with the deployment of those systems.
Great, thank you. So obviously one of the big issues here is around the regulation or not of AI and how all that, what the role of the federal government should be. And so I'm wondering if I go to Dr. Rus, if you have any thoughts on, should AI impact assessments be strictly regulated? Should we just have standards and guidelines to follow? Do you have any thoughts on that question?
Well, so it's a very interesting question because over-regulation can kill innovation. Lack of regulation can cause harm. And so I think the challenge is to figure out where to land in order to balance the two. And I think that it's difficult to imagine a solution that is tailored uniformly to every domain and every application. And I think the jury is still out to really think about how to proceed. But for instance, we could do something as simple as taking any data trained algorithm and assess the quality of the data used to train the model before allowing the model to be used. I mean, this is a kind of a low level of assessment. Maybe you can even call it regulation that prevents models from being trained on bad data. That could be a kind of a low level entry point in this space, especially since we're beginning to see some technical solutions in this respect. I also believe that if you deploy technology in safety critical applications, it's important to find a way to explain when the solution will work and when it will not work. So I strongly believe in the need of some kind of understanding for how the system reaches decisions. Because if you have a physical especially if you deploy the technology in the context of an autonomy or automation task, then knowing what works and what doesn't work is important. And I'm encouraged to see some early results that show a path to get to automatically synthesizing decision trees that explain to people in human understandable form how certain decisions are made by an AI engine.
Great, thank you. Dr. Hebert or Dr. Lee, do you have any comments you'd like to share? If not, we can.
One thing that we need to take into account in regulations is the idea that I mentioned earlier of auditing. In other words, we may not be able to guarantee explainability of the system or transparency of the system, but what we could guarantee is auditing of the behavior of the system in some kind of semi-standardized way, so that we can go back and then take advantage of all the systems that are in operation to better understand and better characterize their operations and their performance. Basically, the equivalent of the AI black box, if you will.
Great, thank you. Oh. Yeah, go ahead, please.
I agree with what Daniela and Marshall said. I guess the thing I would add is that there are a couple of scenarios we don't want to see. One is that we don't regulate and it comes to harm people. The other one, I think it's worse than we regulate, is we regulate but we don't support innovation. That double whammy would be really bad for the future of our economy. Especially, I think the society has come to the realization, as Marshall said, this technology is developed so fast and deployed so fast. And that's the risk that we are watching as citizens and civil society and worried about. In the meantime, a lot of energy and resource has been sucked out of where innovation has traditionally happened really well, which is higher education, public sector, academia, and the innovation, the resources, the compute resource, the data resource, the talent resource have now been so concentrated in the corporate world, in the tech industry world, that it will harm the innovation of our country, of our society, and that I think we need to be careful, because on one hand we're thinking about regulation, on the other hand we also need to think about how to encourage innovation, especially the investment for innovation in the right places.
Absolutely. I couldn't agree with you more. Innovation is what has driven our country to be so powerful, such a leader in so many ways, and it's super important to support innovation, to invest in innovation, to ensure that we continue to be leaders by inventing new ideas, by inventing new solutions, by really solving problems in an innovative way.
Great. So we've got about 10 minutes left, so I wanted to turn to audience questions. And again, for those watching, you can ask questions in the chat or on Twitter at #VPC Live. So following up on really what we were just talking about in terms of regulation, and I know y'all have mentioned this, but with AI advancing at such a rapid pace, and technology in general, just it is evolving so quickly. How can government regulation keep up with and adapt to those changes? Anyone want to dive on that one?
It's important to become more agile. It's important to become more agile. If it takes 2 years to figure out how to regulate today's advancements, well, in 2 years' time, whatever the decision is probably obsolete. And so it's really important for policymakers to understand the tech. It's important for policymakers to be in the same room as the expert tech leaders, and it's really important to have agile processes.
I want to double down what Daniela said. It's so important to get the multi-stakeholder, multi-expert dialogue and discussion going. You know, there is a lot of, at least from our vantage point, we hear a lot of chatters already on the government side in the willingness to look into these technology, to look at how to regulate or incentivize. Please do, we would love to contribute. When I say we, I mean the expert community, and of course the community of other stakeholders. You know, again, in healthcare, from patients to clinicians to caretakers. But that process has to start and has to modernize to a more agile, procedure for that to catch up with the speed of this technology.
So regulation is part of the answer, but monitoring is another part of the answer. In other words, being able to basically watch the technology being deployed, watch its performance and its effects, so that we can learn from that and learn how to put in place future regulations.
So next week we're going to have two former CFO, federal CTOs, Michael Kratzio and Anish Chopra, speak. And I know that from our work on AI, that the CTO office and the folks in the administration working on technology do a lot of outreach. I'm going to put y'all on the spot here a little bit. Do you hear from members of Congress to kind of reach out and get a better understanding of these technologies?
Yeah, we have a lot of communication. We have congressional staff education programs, like similar to MIT and CMU. We have spoken personally. I've spoken with multiple on multiple occasions with the caucuses at congressionally as well as at Senate. I serve on Biden administration's task force for National AI Research Resource, and it's not enough, but HAI, as one of our founding mission, we say that our founding mission is to advance AI's research, education, and policy. So that's a major focal point of our work.
Great.
I would say that MIT has similar programs, and in fact, one of the pillars of the Schwarzman College of Computing is responsible computing, responsible AI, and we're in the process of developing the program for an AI policy forum, whose objective is precisely to bring policy leaders and tech leaders and business leaders to have these kinds of conversations.
Great, that's really good to hear. One other question is, are there practical solutions to give end users more control over how an AI system behaves to address the trust issue?
Well, I would like to talk about a future where we develop the tech a little bit more, and we take advantage of a technology called homomorphic encryption. Now, that is a kind of a mouthful, but it simply means performing a computation without decrypting the data used to perform that computation. Now, homomorphic encryption has been a kind of a darling of the theory community for a long time. We're beginning to see practical applications. We can't solve all problems with homomorphic encryption, but we have begun to solve certain types of problems in this fashion, and including some problems in machine learning related to clustering. And so I am very bullish about the use of, about the development and use of homomorphic encryption, to the point where I imagine a world where everyone owns their data. The data is encrypted, and then people can decide when and where to allow the use of the data for the greater good, while retaining privacy in the process of giving the data for the greater good.
Yeah, I think what Daniela has pointed out is a emerging trend in technology development in AI as machine learning and privacy, or that whole family of possibilities. I'm also personally very excited by this. There are also other technological trends, such as edge-based computing, as well as other kind of learning algorithms that ensure more privacy and security. On the other hand, I think a general education of the public to raise the awareness of what this technology is about. It's rooted in STEM education, but it goes all the way through, so that we're neither swinging between dystopia and total utopia, but really understanding the consumer and users' rights and risks, and moving away from giving up data so easily, being, and all that is really, really important. Everybody looked at Europe has taken a step a few years ago with GDPR. And of course, GDPR has a lot of issues, some people have pointed out, but it was an important step towards giving back users' rights and control of data. And I think more thoughtful policies like that should be needed.
Yeah, I would like to mention as an example of that framework we call AI Fusion, which is basically similar to the ideas that Fei-Fei and Daniela mentioned of privacy, and in bringing the AI computation as close as possible to the data to ensure control of the data and privacy, while allowing sharing of the data for aggregation, things like sharing without showing the data, similar to some of the things that Daniela mentioned. And finally, coming back to the point that Fei-Fei was making about education, STEM education, this is again this, which I agree with, this is again this point of understanding the limitations of the technology. And that is fundamental, and that has to take place across the entire population.
Yeah, I completely agree. We don't need the broad population to understand the deep mathematics of how deep neural networks work or how homomorphic encryption works, but we do need everybody to understand what the technology can and cannot do, what it should and shouldn't do, and what it must do.
And I will let that be our final comment. I apologize to those who asked questions we did not get to. As you can see, we probably could have talked for another hour, but we are at that mark. So I want to just thank our panelists. Really, this has been a fantastic conversation. I so appreciate how busy you are that you gave us an hour of your time. So thank you all. Thank you to our audience. And again, please join us next Tuesday for that conversation with Anish Chopra and Michael Kratsios. Thank you all very much.
Thank you.
Thank you.
Bye.